Year 13, short revision video number 25. So this is a question where we must show detailed reasoning, meaning every step of our working has got to be crystal clear. So figure 8 shows the graph of a quadratic function. The graph crosses the axes at these three marked points. Find the area of the finite region bound by the curve and the x-axis. So of course, that's this region here. Now, it would be a rookie mistake to assume that the equation of the curve is x minus 2 brackets x plus 1, even though we can see the roots at 2 and minus 1. We know this is wrong because if we expand this, we'll get y equals x squared minus x minus 2, which would suggest we have a y-intercept of negative 2, but we don't. We have a y-intercept of negative 4. So this suggests that there should be a multiplicative factor of 2 in front of the whole thing, which will then give us two lots of this expansion, which will give us a y-intercept of negative 2. So the curve, if we expand it, would be 2x squared minus 2x minus 4 as its equation. So that's the key mistake that people might make on a question like this. Rush in, assume that they know the equation without factoring into account the y-intercept here. Now the area is clearly going to be calculated by integrating 2x squared minus 2x minus 4 with respect to x between limits of negative 1 and 2. So that gives us 2/3 x cubed minus x squared minus 4x. And we need to evaluate the integral at these limits. Because the question said show detailed reasoning, I've shown my integration and I'm now going to show the substitution of the limits as well. So 2/3 multiplied by 8 minus 2 squared, which is 4, minus 4 lots of 2, which is 8. Subtract from that 2/3 times negative 1 minus 1 and then plus 4 at the end. And I'm now going to evaluate this on my calculator, and I expect to get a negative value because the region is below the x-axis. Now I end up with a value of negative 9, but the area is of course the positive value of that, which is 9. The negative just indicates we're below the x-axis. Now because your calculator can perform the integration, because this question asks us to show detailed reasoning, it's crucial that we show all of this working here, including the substitution, and we don't just shove everything into our calculator because we won't get all of the marks for this question if we do that. We must show our detailed reasoning throughout.